the science of Artemis II, and a look at the cosmic commode. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. Soon, a crew of 4 will embark on a 10-day mission around the moon and back. But during Artemis II, what will the astronauts actually be doing? We'll speak with NASA's Nikki Fox about the science happening on that mission. Then, also headed to the moon is a very special piece of technology, a space toilet, and it will be the first to travel to the moon. We'll speak with University of Central Florida's Amy Foster about the history behind bathrooms in space and this new lunar latrine. That's ahead on Are We There Yet? Artemis II is set to launch on NASA's SLS rocket no earlier than March, and will send a crew of 4 on a flyby mission around the moon and back. It's the first time NASA is sending humans back to the moon in over 50 years. We've been covering this mission quite a bit during the show, but we recently got some feedback from a reader that asks, what will they actually be doing on their trip? Well, it's a great question, and one that led us to NASA's Nikki Fox. She's Associate Administrator for the Science Mission Directorate at the agency, and knows all about what the crew will be up to during the mission. She joins us now. Nikki, welcome back to Are We There Yet?
Thank you so much.
So this conversation stemmed from a listener who reached out to us asking us what the Artemis astronauts are going to be doing on their 10-day trip. As the head of science at NASA, how could you answer that?
Well, obviously our astronauts are going to be very busy, and they are our best sort of investigative things that we could have in Orion, because if you think about how a human looks at different features, you don't program them ahead of time to say, look at this, then stay there for so many minutes, and then look at this. They are able to, number one, look at the whole thing quickly, pick out the things that come to be most interesting, stay looking at those things for longer. And so it's really exciting to have our astronaut eyes actually working and doing our science and talking to. There'll be a science officer actually in the mission control room. So that is the first time that we've actually had a science officer on console.
Oh, really? That's cool.
Once the boosters separate, they will come into that bay, and they will then be on console for the duration of the Artemis II mission. We have, kind of a science, if you like, back room. We call it the science evaluation room. And in there, we have a team of really, really gifted lunar scientists, geologists, volcanologists, the whole gamut of people who are super excited about the moon. And they will be looking at the images that are coming back, talking to the crew, listening to them, and documenting their observations. And so I think that's like super exciting. They'll be hearing them in real time. They'll be able to talk to them. I mean, just imagine what that's like. And, that'll be sort of setting us up for future flybys when we want to do more lunar operations. We also, of course, we want to think about when we send crewed missions, where are they particularly interested to go from geology perspectives, particularly on the far side of the moon. We'll be sort of setting up that catalog of places that we want to land. Maybe humans, definitely robotic. I want to keep going back there. So that's sort of what the astronauts will be doing in real time. The other science that I'm particularly excited about that we have actually in the Orion capsule with the astronauts is called Avatar. And that is to study the effects of deep space, both microgravity and radiation, how they are affecting human health. And so these are they're on chips about the size of the tip of your thumb drive. And they are sort of like little replicas of human tissue. So this one is bone marrow, because that's a particularly good indicator. Each of the astronauts have provided blood samples, so they are actually like little avatars of the actual astronaut. It'll be so exciting. We have some tissues that will be left here on Earth. The other tissues travel with the astronauts. You may say, why are you bothering to send tissues when the astronauts are going, I can dissect those tissues when they come back and really look in detail and in depth at anything that's changed, even on the cellular level. So it's such a great opportunity to have. You can also look at the crew themselves. We do a tremendous amount of observation on them when they come back, but actually being able to really look at the cellular level at the impact of deep space on our future astronauts as we think of going not just to the moon, but onto Mars.
Broadly, as NASA's head of science, what questions do you want answered from the observations these astronauts will make on Artemis II?
I mean, they're going to see the far side of the moon, and that's just not something that we've ever really had a chance to study in huge detail. It's easy to look at the near side of the moon. It's hard to look at the far side of the moon. Of course, we have like our Lunar Reconnaissance Orbiter that has been doing such a great job mapping out the moon for us for so long, but to really be able to hear the astronauts and interact with them about just what they're seeing and what features they find particularly interesting. I mean, really, what is it like? What's it like on the far side of the moon? People talk about science being on this mission, but exploration is science. I mean, when you go on a trip, go to somewhere you haven't been before, what's the first thing you do? You look around you. You decide where looks interesting and you go visit. That is what we do. We're naturally curious as humans. And so everything we do is scientific exploration. So many questions that will be answered. I am really interested in the effect on the human body because as the head of science, I'm looking forward to more Mars missions as well as more lunar missions, always looking for volatiles, looking for the presence of water on the moon that we could actually use to sustain our astronauts. So but I think about it as building on the last mission. We had science on Artemis I. Artemis II, we've got Avatar, we've got the real-time work with the astronauts, and then Artemis III, obviously real-time with the astronauts is still a huge thing, but taking down a number of experiments as well that the astronauts will interact with. So every one will build on what's come before.
Nikki, you mentioned this at the start. It's something that I'm still stuck on, the fact that you've got science people on console talking with these astronauts in real time as they are making these observations. Tell me a little bit about the benefits of that.
We could tell them before they go up, look at this feature. And when they get up, they're like, that's really not that interesting. But the piece right next to it, oh my goodness, let's talk about that. And sort of having, our scientists looking at what they're seeing. I mean, obviously they have cameras that are part of the experiment as well as what they're seeing with their eyes. We have one of the crew that's going to be literally talking about what the crew are doing and how they're reacting. Super cool. I mean, for me, just the inspiration behind this, it is an Apollo 11 moment.
And Nikki, that's been the case for years when people ask, why do we go back to the moon? Why do we want to send people to Mars? Is having a human there is far more beneficial than having a robot, right? Is this kind of a proof of concept that we're going to see with Artemis II?
I think so. I'll challenge it a little bit with our robotic uncrewed missions. We can go into areas that crew would never survive. So, for example, the atmosphere of the sun, flying past Pluto, going into the intense radiation environments at Jupiter. A human would never survive that. So we often send our robotic explorers either ahead to make sure it's safe, which of course is what we're doing on Mars right now. And then we can send them well beyond to do this incredible sort of pushing the boundaries of science. There are so many opportunities with Artemis II, and it isn't just about the astronauts and what they can see. It's also what our heliophysicists are doing to keep those astronauts safe. Space weather is a huge thing. The sun has been so active. We get a lot of space weather impacts here on Earth despite protective magnetosphere. But once you leave that, you are exposed to things like the big coronal mass ejections, the big solar storms, those big X-class flares. We need to make sure that we are monitoring everything and providing up to the second space weather forecasting for our astronauts. That's what we do at NASA. We actually do our space weather forecasting.
You're listening to Are We There Yet, the radio show exploring space exploration. I'm Brendan Byrne. We're speaking with Dr. Nikki Fox, Associate Administrator for the Science Mission Directorate at NASA. We're talking about science on the Artemis II mission and beyond. And I'm going to have to say this in defense of what I said. If any of our robotic rovers are picking up this conversation via the FM signal that is going out, I meant no disrespect to you all. Thank you for doing the groundbreaking work that you all do there. So thanks for putting me on the spot and calling me out there, Nikki.
Right now, I'm getting angry letters from the Perseverance rover.
I'm sure you are. I'm sure you are. You know, Nikki, you brought up something really interesting, and I want to end our conversation on this because you and I have spoken before, even before you were in this position. My first mission I ever covered as a space journalist was EFT-1. In just that 8 to 10 years since that's happened, we are learning so much more about our sun and moon system. Can you just reflect on this kind of new chapter of understanding that we are embarking on in this past decade and what will be in the decade to come?
I will just say the energy that is just around space, around science, around exploration is just incredible. I think we have much quicker access to space. We are looking at how we really embrace the commercial sector through things like our CLIPS programs, looking at what that would look like for Mars. To quote my own administrator, more shots on goal is what we want to see. We want to be looking at how we actually accelerate the pace of getting science off this planet and out to another one, whether it is around the moon, which of course is the big focus right now, Mars, or beyond. In this decade, we'll launch incredible missions. Later this year, we'll launch the Nancy Grace Roman Space Telescope with a field of view 100 times the size of Hubble. I mean, that's incredible. We have the NEO Surveyor mission that will be actually cataloging and searching for a huge number of near-Earth objects. Of course, we had all the excitement last year with Comet 3I Atlas wandering into our neighborhood. And so, really pushing those things forward. On the smaller scale, our heliophysics division will launch something called Sunrise, 6 tiny CubeSats that are actually forming like a giant radio receiver in the sky to be able to track unbelievable detail what's coming from the sun and how that will impact us here on Earth. And then in 2028, launching the mighty Dragonfly, going off to Titan to look at what is in that ocean, what is on the surface of Titan. So really exciting stuff for us, really pushing what we're doing. All of our divisions here doing incredible things. Last year, we launched the NISAR mission, looking at our planet with unbelievable detail, kind of at the Earth, at the how the Earth changes, and even being able to sort of sense volcanic action before it's happening, looking at little tiny land, when we think of earthquakes, but little tiny micro earthquakes that could be the precursor to a big one, helping us protect our planet. So everybody already talked about Avatar growing, plants on the moon and then onto Mars. So I think that it's just the sort of the momentum that we have going, really embracing small missions as well as the really big ones. Having our astronauts on the moon, thinking about how we would protect our astronauts and send them to Mars. I don't think there's been a more exciting time where I feel like it's almost like we're standing in the time before. You just know the next decade is going to be mind blowing, and we are just standing here waiting for the next greatest things and building on everything that we do today. What's impossible today is delivered tomorrow. NASA science 24/7. So, that is what we do. And it's just a really, really exciting time to be doing it.
Lots of shots on goal. I like to hear that. So Nikki Fox, the head of NASA Science, thank you so much for joining us.
Thank you so much.
And if you got a question for us, well, send us an email. It's arewethereyet@cfpublic.org. Still to come, the history of toilets in space.
There was no toilet for the Apollo astronauts, the Gemini astronauts, or the Mercury astronauts going all the way back. We don't actually get a toilet for the astronauts until Skylab.
Boldly going. That's ahead on Are We There Yet?
Support for Central Florida Public Media comes from the University of Central Florida, offering their Masters of Science in Data Analytics program. Designed to enhance skills in data analysis and machine learning, the new Artificial Intelligence track offers specialized courses to deepen understanding of AI technologies and their applications. More at ce.ucf.edu/data.
You're listening to Are We There Yet? From Central Florida Public Media. I'm Brendan Byrne. The Mars rovers are making decisions all over the red planet by themselves. That's right, Perseverance and Curiosity can use their tools like cameras and lasers to study objects on Mars autonomously, then report back to scientists here on Earth. So how do they do that? Well, we'll take a look next week on Are We There Yet? But for now, we are continuing to talk about Artemis II, specifically the toilet that is heading to the moon. Compared to the Apollo program, where there were no toilets, this commode stands as a testament to how NASA technology and missions have advanced. Here to talk more about the history of astronauts using the bathroom in space and this new toilet being sent to the moon is Amy Foster, a professor of history at the University of Central Florida. Amy, welcome back to Are We There Yet?
Thank you.
So we're talking about the toilet. Of course, we had to make a call to you about this. Before we talk about this historical moment about this lunar latrine or this cosmic commode that's heading to the moon soon, let's talk about the history of the toilet, because the Apollo astronauts did not have one, right?
No, there was no toilet for the Apollo astronauts, the Gemini astronauts, or the Mercury astronauts going all the way back. We don't actually get a toilet for the astronauts until Skylab. The idea was that these astronauts would be up for about a month for each mission, and the solutions that they had for urination and defecation going back to Apollo simply would not suffice for a month-long missions. So we've had a toilet on space vehicles for a while, but what they had during Apollo was pretty primitive, to say the least.
In your most academic way, can you explain how that actually happened?
First and foremost, you don't just go to the toilet in the way that we think about it on Earth. Everything is done in a toilet on Earth, but those processes need to be separated out for space flight. So there's urine collection and there's fecal collection. And that's true even in the toilet eras because of how that material is processed. So ultimately, urine is collected through a hose, usually, so that it can either be dumped overboard and not brought back because it can be heavy, or samples can be saved for medical tests down the road. All fecal matter is collected separately and usually stored and brought back. We don't want fecal dumps overboard. So with the Apollo astronauts, they had something called a urine collection device. NASA loves its acronyms, so it's a UCD. It sort of looks like the front half of a diaper, except that it's plastic rubber. So it just looked like this loincloth in the front, but it had a hole and there'd be its sheath to kind of keep things from floating around. This is all connected to a hose that goes into a container, which can be dumped. So they needed to have a way to not only be able to do that in a suit of some sort, but because there is no toilet space on Apollo, they had to find a way to do both of these processes separately. Fecal collection, there's nothing private about it. It was a collection bag that had kind of at the opening, it had stickers that you just kind of, stuck to your backside so that everything was enclosed. And then you could then rip that off when you were done, and those sticky sides could go together and you could close it. That all just got saved and brought home. So, basically, like I say, there's nothing private about it. You can the best you can do is kind of go find a spot, I guess, if you wanted to float into the LEM to get a little privacy for that. But it's low tech, but it worked. And I think particularly for when you go and look at Mercury, Gemini, and Apollo, even though Apollo had a little more room, they're always thinking about, how do we keep this space to a minimum? But I think the other thing that we have to think about during those first three programs in the 1960s is they really were all designed to get to the moon on a deadline. And toilets are not easy contraptions to build for spaceflight. They're fairly complex because we have the benefit of gravity on toilets on the surface of the Earth. That has to be replicated. And it's done usually through systems of vacuums. And they're pretty complicated pieces of technology. In fact, one of the early shuttle flights that Judy Resnick was on her first flight, the toilet failed. And so they actually brought the mission home about a day early. There were sort of solutions, but they're like, this simply isn't, feasible for any longer than we need to. So to avoid having them be uncomfortable, simply bring them home a day early. So, the toilets are complex, but Apollo was just very basic and very simple.
How did the Apollo astronauts describe that process of using such a simple collection, like a sticky bag to your derriere?
I haven't asked any of the Apollo astronauts what they thought of that. But what I do know from some of the early women astronauts' experiences is they'll do what they need to do. It may not be pleasant, but first and foremost, they want to fly in space.
Mm-hmm.
And so they will make that happen. One of the things that became important in terms of, those biological functions was not just what happens during the mission, but how do they manage it for launch and landing? Because you're strapped into a seat. You can't get up and go use anything. Now, that urine collection device that the Apollo astronauts had, that worked for launch and landing because it's something they can wear under their suit. They can be doing that in the privacy of their own suit, and it's not a concern. With the introduction of women astronauts during that launch and landing, it was always trying to figure out how do we make something that works for them, because we can't just have essentially like a sheath that doesn't work. So a lot of the devices that NASA was designing, even for those first women, were not necessarily things that were comfortable. And the urine collection device for women ultimately is like a diaper. I remember talking to Ray Seddon about it, and she said, I took one of those home and I sat in the tub and I tried it out. It may not be pleasant, but this means I can fly. They will simply deal with it. But it's certainly the systems that we had during the Apollo era are not something that you necessarily want to do when you have both men and women on board. There's a modicum of privacy that you want for some of those things. And, having men and women needing to use those same systems is simply not adequate. And for that reason, when the shuttle was developed, knowing that there were going to be men and women on board, there also was more space in the shuttle working and living quarters. Then you could dedicate some space to a toilet. And that's really why we see the toilets being incorporated into some of these later flights, both because they're mixed sex crews, but those vehicles are a little bit bigger. And that makes it possible to have a restroom space. With Artemis, it's interesting. When you look at the layout, it's actually the restroom is in the floor. Whatever space they make it work. And we think, how does that work? Well, you simply just float into it. Up is whichever way your head is. And so they float into this little compartment in the floor, and that's where the toilet is. So, they have that privacy for however many minutes they need, and that works great. But those toilets themselves still are separated so that they're collecting urine separately through a hose, and then fecal collection is something that looks more like a toilet.
You're listening to Are We There Yet? From Central Florida Public Media. I'm Brendan Byrne. We're speaking with Amy Foster, professor of history at the University of Central Florida. Of course, we were talking about the toilet. Amy, you mentioned that there have been a lot of design changes. They've incorporated the input of the astronauts, including the women astronauts when they're making that toilet for the space shuttle. Now, as we're looking at the toilet for Orion, how big of a moment is this in human space flight, the fact that we are sending a toilet to the moon?
It is a big deal. I mean, this is being able to use the restroom both with some privacy, but that's an absolutely important function. And you need to make sure that the astronauts can evacuate their systems effectively. The last thing you want is for somebody to end up with a urinary tract infection on the backside of the moon. So we need to make sure that this is a system that works and that it works well. The additional thing, making sure that these toilets have vacuum systems that are going to function well and function for the whole mission is also important. These really are the most complicated toilets you could imagine, and making sure that these function well and consistently, as well as making the process as simple as possible, is important. And so having the astronauts input their ideas on what makes them work well and what makes them not work well is an important part of the design process. This really is an absolutely essential part of these missions.
And to me, Amy, it sounds like, we're talking about this, the Mercury, Gemini, Apollo missions, they all had, the bags. It was a quick trip. That's all they needed. Then you get to Skylab, more extended presence in space. We see a toilet. We see Space Shuttle. We see ISS. Is the toilet an indicator of our ambitions for longer duration missions in space? Like, if you see a toilet, do we know that we're boldly going for a very, very long time?
I think that is fair. Like I say, there's always ways to make do in the short term. But, in addition to being concerned about the health of the astronauts, that's also one little space they can go and be alone. And even though generally all of these vehicles, they're small quarters. And so having the opportunity for a little bit of privacy for those personal things matter, but also just a little bit of quiet. They are still living in space. And so all of the elements of living need to be available to them.
Nothing more like the human experience than using the bathroom.
Exactly. Yeah. And it's something they have to test. One of the things that NASA did do is they built a toilet simulator for the Artemis astronauts to try out. There is a bit of a learning curve. You have to make sure that you are strapped to the toilet if you're doing those fecal processes. The other thing, that in addition to that vacuum providing replacing gravity, is it keeps everything from floating away, because then you have a cleanup process. And the last things that astronauts want are, tiny bits of poop floating around in the capsule. That's something they then would have to clean up. And it can be truly a disastrous thing if, you have fecal material getting into switches and things like that. You simply can't have it. So, making sure that the toilet is not only going to function consistently, flush after flush. They also need to make sure that, the astronauts can comfortably use it. They're going to use it every single day, and they need to know how to make the system work well. And it's a different process. Like I say, all urine is collected through a hose. Each astronaut has their own funnel that they attach to the end of the hose. And so that's separate from fecal collection. And so it's literally is two different processes, and getting used to how those systems are set up is one of those things they also have to practice.
Amy Foster, thank you so much for joining us.
You're welcome.
That was Amy Foster, professor of history at the University of Central Florida. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts and Spotify or wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTYSpace. And if you got an idea for a future episode of the show, or you want to join us as a guest, well, reach out. Our email is arewethereyet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our intern is Orion Boone. Our producer is Marion Summerall. Editorial guidance from Latoya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.